Hello everyone. In this video I'm going to talk about the chi-square test of independence, and I am Hamajoda Ibrahim. So the content of my presentation is going to be, first I'm going to talk about the introduction to chi-square test. Then I'm going to give 3 examples of chi-square test. Then I'll talk about the Cramer's V interpretations. It's going to be a table that's going to interpret any value you get from the Cramer's V. After that, I'm going to talk about the takeaways. Then I will open room for your questions. So the chi-square test for independence is used basically to determine if there is a significant relationship between nominal variables. It can be used for both two and multiple group studies, and that's what makes it very important in statistics. So usually while carrying out the test, our null hypothesis, of course, states that there is no relationship between the two variables we're testing, and our alternative hypothesis states that there is a relationship between the variables being tested. So we only carry out the Cramer's V calculation if the null hypothesis has been rejected. And the reason why we calculate the Cramer's V is to actually determine the strength of the relationship that has been found. So that's usually found in cases where the null hypothesis, which states there's no relationship, is being rejected. So we accept the alternative hypothesis, which states there is a relationship between the variables. So we do the Cramer's V in order to determine what is actually the strength of the relationship between the variables. So the first chi-square test we did gave us no significance. It was, in that example, we had as our null hypothesis that there is no relationship between number of cars and number of defaults, and our alternative hypothesis states that there is a relationship between number of cars and number of defaults. And after calculating our p-value, which gave us 0.3, which is much higher than the significance level of 0.05, we actually didn't fail to reject the null hypothesis, and so there's no relationship between the number of cars and number of defaults. The second chi-square test we carried out was also a test where we got no significance. That is, we failed to reject our null hypothesis, which states there's no relationship between comfort and number of defaults. And we have as alternative hypothesis in this case that there's a relationship between the comfort and number of defaults. So the comfort and number of defaults are just part of the data set that was provided. And in this example, we have our sample space is 150 and the chi-square value that was gotten is 6.681. The third and last chi-square test that was carried out was one in which we found a significant result. So the null hypothesis in this case was there is no relationship between the number of cars and comfort. Again, these are just gotten from the data set that was provided. And our alternative hypothesis states that there is a relationship between number of cars and comfort. So with a p-value which is very, very low and tends towards 0, we actually reject the null hypothesis because the p-value is much less than our significant value, which is 0.05. We have 9 degrees of freedom in this case, and our chi-square value gave us 450. So this table actually shows us the interpretation of Cramer's V values, which shows the strength of the relationship between variables. So when we get a Cramer's V value of 0, it indicates there is no relationship at all to consider. In case we have a value ranging between 0 and 0.15, it means there is a very weak relationship. Actually, the comment we can say about it is that there's no relationship to consider. A value obtained between 0.15 and 0.2 shows a weak interpretation again, and a value between 0.2 to 0.25 shows a moderate interpretation, and a value between 0.25 and 0.3 shows a moderately strong. So it's a desirable strength. Values between 0.3 to 0.35 shows a strong relationship, and it's very desirable, but it's not going to be easy to achieve. A value between 0.35 to 0.40 shows a very strong relationship, and 0.4 to 0.50 it's questionably strong. A value between 0.5 to 0.99 means the relation is redundant, so that might need you to actually contact the professor because the variables are likely to be similar or the same. So a value of 1 gives a perfectly symmetric relationship, which is very, very rare. So there you can have a value above 1 or below 0. Actually, the values should be between 0 and 1. So what we can take away from this presentation is that the chi-square test helps us to find the relationship between two nominal variables. The Cramer's V takes values between 0 and 1, as I just said. With p-values of less than the significance level of 0.05, the null hypothesis is rejected, and with values greater than with values greater than that, we actually fail to reject the null hypothesis. When the null hypothesis is rejected, that's when we actually carry out the Cramer's V calculation to determine the strength of the relationship. So I thank you all for watching the videos, and if you have any question, please just put it in the discussion area. Thank you very much once more.